Good day, respected examiner, faculty member, and my academic advisor. My name is Mustafa Ahmed Al Qatari, and today I'll present my individual project for EN 8905 Energy, Environment, and Sustainability. The title of my assessment is Hybrid Energy System, a Sustainable Future for Rural Electrification. This assessment investigates how future hybrid energy system can provide a cleaner, more reliable, and more sustainable electricity than conventional diesel power system. Rather than focusing only on electricity generation, this project evaluates technical performance, environmental sustainability, economic visibility, and social impact to determine whether hybrid renewable energy system represent a better long-term solution for isolated communities. The first issue is the global energy access challenge. Many remote and off-grid communities still lack reliable access to electricity. In this location, diesel generators are often used as the main source of power. Diesel generation is dispatchable and technically simple, but also creates major long term problems. It depends on continuous fuel delivery, exposes communities to fuel price changes, and requires regular mechanical maintenance. And the products also produce greenhouses, gas emissions, and local air pollutions. Access to reliable electricity remains one of the world's greatest engineering and sustainability challenges. Millions of people living in remote and isolated communities still depend on diesel generators because extending the national electricity grid is often technically difficult and economically expensive. Although diesel generators provide reliable electricity, they also consume large quantities of fuel and requires continuous maintenance, expose communities to fluctuation, fuel price, and release greenhouse gases into the atmosphere. These challenges directly relate to three important sustainable development goals. SDG 7 promotes affordable and clean energy. SDG 9 support resilient infrastructure and engineering innovation. And SDG 13 encourages reducing greenhouse gases emissions and protecting the environment. This assessment therefore investigates whether hybrid renewable energy system can address these challenges more effectively than conventional diesel generation. The first energy system assessed is the conventional diesel powered electricity system. Diesel generators remain one of the most common solutions for remote communities because they are simple to install and can provide electricity whenever fuel is available. However, continuous diesel operation creates significant environmental and economic challenges. Diesel generation depends entirely on transport fossil fuel, resulting in high operating cost and regular maintenance requirement. Every liter of diesel burned also releases greenhouse gases and atmospheric pollutions, contributing to climate change and reduce air quality. Although diesel systems remain technically reliable, their long-term sustainability is increasingly questioned. Therefore, the key engineering question become: can hybrid renewable energy system provide the same reliable while significantly reducing fuel consumption, emission, and operating cost? To answer this question, the next section compares diesel generation with a proposed hybrid energy system. The proposed future energy system is an AC-coupled hybrid microgrid designed to improve sustainability while maintaining reliable electricity supply. Unlike the conventional diesel system, renewable energy becomes the primary electricity source. Solar photovoltaic panels and wind turbines generate electricity whenever renewable resources are available. Any excess renewable energy is stored in a battery energy storage system. During periods of low renewable generation, the battery supply the electrical demand before requesting additional diesel generation. The energy management system continuously monitors renewable generation battery state of charge and electrical demand, voltage, and frequency to determine the most efficient operation strategy. As a result, the diesel generator operates only when renewable generation and battery storage are insufficient, significantly reducing fuel consumption and emission while maintaining system reliability. To evaluate the sustainability of both system, fuel consumption was compared under the same 1 megawatt electrical demand. Based on the standard engineering assumption, a conventional diesel generator consumes approximately 260 liters of diesel fuel every hour. This corresponds to approximately 6,240 liters every day. Over 1 year of continuous operation, fuel consumption exceeds 2.27 million liters. In comparison, the proposed hyper system uses renewable energy as the primary power source. Diesel generation is required only during period of insufficient renewable generation or low battery state of charge. Consequently, diesel fuel consumption decreases to approximately 80 liters per hour. Annual fuel consumption decreases to approximately 700,000 liters, representing an estimated saving of more than 1.5 million liters of diesel every year. This reduction significantly lowers operating cost while improving long-term sustainability. Fuel consumption directly influences greenhouse gas emissions. Every liter of diesel fuel releases approximately 2.68 kg of carbon dioxide during combustion. Therefore, the diesel system produces approximately 697 kilograms of carbon dioxide. Under continuous operation, annual emission exceeds 6,000 tons of carbon dioxide. By reducing diesel operating through renewable generation and battery storage, the hybrid system decreases emission to approximately 1,800 tons per year. This represents an estimated annual reduction of more than 4,000 tons of carbon dioxide. In addition to reducing carbon emission, lower diesel operation also decreases nitrogen oxides, sulfur dioxide, particulate matter, and local air pollutions. These environmental improve directly and support Sustainable Development Goal 13 by reducing climate impacts and promoting cleaner energy productions. The comparison demonstrated that the proposed hyper-renewable energy system provides significant improvement over conventional diesel generation. Technically, renewable generation combined with battery storage improves system flexibility and reduce dependence on continuous diesel operation. Economically, lower fuel consumption decrease long-term operating expenditure while improving overall energy efficiency. Environmentally, renewable energy sustainability reduce greenhouse gas emissions and atmospheric pollutions. Socially reliable and sustainable electricity improve healthcare, education, communication, and community development. Overall, the engineering assessment indicates that the hyper-renewable energy system provide a more balanced and sustainable solution for future rural electrification than conventional diesel-only generation. Having established the technical and environmental benefits, the next section will present the engineering simulation used to validate performance and the proposed systems. Economically, the proposed microgrid requires a high initial capital investment of approximately 1.98 million US dollars. However, the projected levelized cost of energy is between 12 and 18 cents per kilowatt hour, with an estimated payback period of approximately 1.5 to 2 years. As a part of the project, I also carried out a social awareness activity. I explained the relationship between SDG 7, diesel generation, renewable energy system, and hybrid microgrid to a small group of participants in my workplace. Participation was voluntary, consent was obtained, and feedback as well was obtained. I use pre-session and post-session question to evaluate participant understanding. The result showed improved awarenesses of SDG 7 and the limitation of diesel-only generation, the benefits of renewable energy integration, and the role of battery storage and intelligent control. The activity demonstrated that public understanding is important for successful adoption of sustainable energy technologies. It also showed the engineering communication must be clear, accurate, and connected to the real community needs. In conclusion, this energy environment and sustainability assessment demonstrate that the choice of energy system must consider more than electricity generation alone. A sustainable solution must balance technical reliability, economic affordability, and environmental protection, energy security, and equitable access. Support generation. The system combines solar and wind generation, battery storage, intelligent energy management, and diesel backup. The simulation meet the project demand target approximately 1 megawatts and demonstrated rapid stabilization under sudden load change. The project support SDG 7 through reliable and affordable energy access, SDG 9 through resilient infrastructure and innovation, and SDG 13 through reduced fossil fuel dependence and lower operational emissions. The work has strengthened my understanding of how detailed engineering design can support broader environmental and sustainable objectives. This concludes my presentation, and I'm now prepared for your question. You are welcome to ask anything in the comment and to email me as well. Thank you all for listening.